So we're going to look at binomial division right here. I was just looking back through and realized I didn't have a video for it. These are two examples here that we can see that are going to be useful to us. So, for example, in this first scenario, if I said divide x squared minus 4 by x plus 2. Well, this setup, as you can see here, I'll just write it out at the same time, x plus 2 and then x squared minus 4. Only problem is with something like this is that we want our placeholder. So we're going to add in a 0x in that case. And essentially for binomial division, the first thing that you always evaluate, and what matters more than anything, is just the first two parts of the expressions. What I mean by that is when I'm looking at this, the first thing I'm going to be asking myself, what times x is going to give me x squared? So what times x is going to give me x squared, yeah?
X.
Just an x, right? So I would just say just an x. So I would put that above. And again, when I say the reason why I put that 0x in there is I want things to stay organized. This is going to help me stay organized. Your next step is to multiply that by not just x, but also by 2. So x times x is x squared. X times 2 is plus 2x. Now I can go ahead and subtract. And if at the next stage here, if x squared and x squared don't cancel each other, if those two things don't cancel each other because they're not the same thing, then you done goofed. Because you shouldn't have anything here anymore.
Would just like x squared times x, would that be x cubed?
X squared times, say that again?
X.
X squared times x would give you x cubed, yeah.
Okay,
So then you're
when you're after your times and you're just
adding the exponents. Yeah.
Sir, do we have this?
From many moons ago, yeah.
Yeah.
But so let me just finish this guy because I'm recording. I want to keep this tight. X times that, x times that. I basically restart this process again. So it's very monotonous in some ways, but it still works. In this case, I'm still going to ask myself what times x, but in this case, I'm going to be evaluating just the first guy down here. What times x is going to give me 2x? Okay. Minus 2. So then I would put that in here, minus 2. And then I would say, okay, x times negative 2 times x will give me a negative 2x. Okay. So a negative 2x. And negative 2 times 2 would give me a negative 4. So now when I subtract these guys here, they cancel each other out. And I'm going to have 4. If you look at it here, minus 4 subtracting a negative 4 is going to end up leaving me with like no remainder here, which is doesn't always have to be that way, right? As you can see down here, you can have a remainder of 2. That's perfectly fine. But the answer in this case would be if I did binomial division, my final answer would be x minus 2. Okay. So we'll do one more really quick. There's another example if people want to take a quick gander at that guy there. I'll just try this one here. If I'm saying this is the setup, I'm just going to immediately write it, right? Like m minus 8 divided by m squared 7m minus 11. And so you just evaluate again the first parts of it. So what times m would give me m squared? Well, just 1m. So m times m is m squared. M times negative 8 is negative 8m. Now I just subtract. The m squareds cancel out. The negative 7m subtracting a negative 8m means I'm going to be left with positive m. This is where people will make their mistakes, right there on that subtraction. Especially when it's a negative, subtracting a negative. They're probably going to mess up with that one there. That's where I would like pay the closest attention when I'm doing the subtraction part of it. And then now I can just break down negative 11 and then ask myself, okay, well then what times m would give me m? Well, that would just be 1. So I would literally just now say 1 times m is m. 1 times negative 8 is negative 8. And then I still subtract. a negative 11 subtracting negative 8 means I'd be left with a negative 3 as a remainder. So your final answer in that guy would be m plus 1. You can write remainder negative 3. The ones that you'll see on the C1 right now, it should be perfect. And it won't result in the one in the C1 because it's like a C cubed that you're doing. It's not going to result in just like a binomial. It's going to result in a trinomial for that guy there.
Okay. Can you just check if this